In our third class of Earth surface environments or geomorphology class, we were speaking about how rocks would move, so how slope failure would result in mass motions. And here we were speaking about then four main types of processes: rock falls. There were also what we called slide. Also we had flow and creep. Slide or flow often would be exchanged in the different kinds of explanations of mass motions. There would be perhaps more variants of these movements being listed, and as I said, sometimes slides would be the second, flow would be the second. But usually this is kind of an order that would be applied if you just look up on the internet what other like geomorphologists would be speaking about. Usually they would be in general saying that the rock fall is the first one, is the most simple, which would mean that individual pieces of rocks would be falling off a kind of surface, which would be a slope, obviously. Individual pieces of rocks, sometimes they would be even rolling on the slope as well. So fall doesn't mean, by definition, free fall, but the fact that individual pieces of grains, independently actually from the size, would be moving. They do not create a kind of flow. A slide would be what often would be said a rock slide or landslide, so often used. So a slide would be a kind of movement on the slope where there is a kind of plane so kind of a slide plane or such. And this would often also be where we would have slumping or slump, and in this case it's not parallel to the slope but more like these kinds of curvy shaped planes where the movement would happen. And that's when we said that in certain places the land would become lower than in its original position, and in others it would come up and become like higher compared to the original surfaces. That's why in some places we would have these like steps developing on the slope, and these are all thanks to these shear planes by which the sliding would happen. So a specific form of slide is slump or slumping. For flow, we said that it can be related to slide, but often to fall as well. So whenever we have a kind of surface, a kind of slope where a certain mass of material starts to act like a liquid and it would move as like water would, so would flow independently actually from the amount of water saturated or independently from the wetness. If we think about dry sand can act in the form of like flowing as well, even though it's not wet. But in many cases, whenever the slope material would be very wet, saturated, oversaturated, it would be full of moisture, full of water, that would be a point where this kind of flow could develop. A specific form of flow, because we said that flow often would be relatively quick, then a specific form would be solifluction, which is the earth or the soil material flowing on the top of the surface, but relatively slowly. So slow form of flow would be solifluction, or when we are speaking about how the permafrost or ice-covered surface would be behaving, that would be jelly solifluction or jellyfluction. You found both names, jelly solifluction or jellyfluction, being used. So that would be the slower form of the flow. And creep will be somewhat similar to solifluction, but it would be very, very slow, and it could only be traced by moving of like fences or trees and their trunks taking new shapes. And this is then again a very slow movement of the surface, the land surface. So that is creep or creeping. We also said that we can divide these depending on to what extent they're wet or act like a fluid. We could also say that there's a difference in speed. So falls, slides, flows can be fast, but slide, flow, and creep would be often very slow as well. We also say that the size matters. So falls, even though we have a big boulder, a large piece of rock, compared to a slide or especially a flow or a creep, is relatively small. Creep would usually mean the whole mountainside moving. A flow could have a distance covered like of a couple of kilometers. And slide usually is smaller, but still involves more movement of material than the fall itself. So these are just some of these kinds of variants or factors that we could think of. Again, fall usually is dry. Slide would involve some moisture or some water. Flow can be together with a large amount of water. So flow can happen like in the case of a dam failure. Creep, it doesn't really make difference if it's wet or not. But for the flow, again, it's tricky because even dry materials, when they are in such a mass, can act in a way as a liquid would. So these are just some of the main features of falls, slides, flows, and creep, which are then the main forms of mass movements. For the lecture 4, which is related to all this, I just want to here think about slope stability. What does it mean? Is that we have a slope. When actually does it start to move? Usually it will be near instability. So rocks would still be in place, but very close to movement. whenever there's a higher amount of precipitation, then flow could happen, or if there's high wind, or we can think of contraction and expansion of rocks due to the sunshine and the cold winter. So falls can happen thanks to this kind of process. But anyway, we can think here of the rock material itself. So the rock strength, or to what extent it is intact. Rock strength is a factor. Also, we can think of here to what extent the structure of the rock material has changed. So in the first place, we can say weathering, or weatheredness of the rock, and also spacing of any joints. So how these cracks, joints between the masses of the rock would be behaving, or how they would look like. So that would be spacing of the joints. Also related to this jointedness, we can think of the orientation. Orientation of the joints. So how, like in this case, the cracks would be parallel, or in what degrees the cracks would be compared to the slope itself. We can also say to what extent these are wide cracks or joints here between the larger masses of rocks. So width of the joints. Width of the joint. And also we can think about the continuity of the joints, so whether there are larger structures, whether they are connected. So that is then again continuity. And finally, we need to think about whether water is actually filling these joints. So to what extent water is included in this whole equation, it's very important. If it's wet, it will be more prone to slope failure, to become a material that is involved in mass movement. So these are then the 1, 2, 3, 4, 5, 6, 7 main kind of factors that would drive the slope stability. And this is also what we said would be included in the kind of Selby or Selby's kind of classification of slopes. So these are then the factors that we need to take into consideration, and this is what we need to memorize for the exam as well.